Hi, everyone. I guess you can see my hand a little bit with this virtual screen. My name is Jevin West, and I'm an associate professor here in the Information School at the University of Washington and one of the co-founders of the Center for an Informed Public. Thanks so much for joining MisinfoDay and for participating in this specific module, which I will be talking about. Misinformation that comes wrapped in numbers, data, and statistics. At the end of 20 minutes, I'm hoping to focus your attention on two topics in that area of data reasoning: data visualization and selection bias. We'll also talk about some tips for spotting misinformation and disinformation that comes wrapped in data and statistics. I'm going to share my screen because I'm going to show some slides today. This presentation was done in collaboration with my colleague, Carl Bergstrom. I will be presenting today, but we typically co-present on this topic quite often because we have a class like this at the University of Washington where we spend the entire quarter talking about the art of skepticism in a data-driven world. This particular 20-minute discussion will be focused on MisinfoDay, a MisinfoDay module that you're all a part of. So that's enough with introductions. Let's get started. And also, by the way, this is a virtual recorded lecture module, but happy to meet in person, hopefully at some time on campus. So thanks all for joining. I also want to note that this is in collaboration with the Center for an Informed Public at the University of Washington and the Edward R. Murrow College of Communication at Washington State University. So this is a collaboration across the states. We might be rivals on the sports fields, but we're major collaborators when it comes to this issue of misinformation. All right, let's get started. As many of you know, we are inundated with information on our phones, on our tablets, on our computers. Everywhere we go, there's information. More and more of that information comes in quantitative form. And many of you have seen this quantitative form, of course, at school. But if you follow the news, or you're looking at TikTok videos or Twitter, Facebook, or any social media platform, you're going to see more and more tables and charts and statistics and numbers and percentages. And that's just part of the quantification of our world that we've seen for a long time. It's something we've done in science for a very long time, but we're seeing more and more of it in everyday life. And we've seen a lot of it during the COVID pandemic. And so my goal and my colleague's goal, Carl Bergstrom, who's also a professor at the University of Washington, is to try to train our students and the public and you on skills and tips for being able to call out when you see misinformation in a table or graphic. So let's start with an example. This is an example of a chart based on real data that was published on a site called Statista. And Statista isn't about trying to trick you or anything. They organize and sell data, and it can be very useful. And this isn't a group that's trying to make one case, political case versus maybe another case that could be made. But they showed here what appears to be the leveling off of carbon dioxide emissions. And if you read the title here, it says carbon dioxide emissions from global fossil fuel combustion and industrial processes from 1751 to 2016. And if you read the text over here, it says over the past few years, carbon dioxide emissions worldwide had stabilized relative to previous decades. And if you look here, it does look like maybe it's stabilizing. In fact, it seems counter to a lot of things that we hear when we hear about fossil fuels. And if this is all you saw in a TikTok video or a Facebook post, you might think, things are stabilizing relative to what we've seen in previous decades. But if you look closer at this chart, you'll see something wrong. A I'll let you look at it for a second. Maybe you can pause the video at this point and you can look at your classmates and say, do you see what's wrong? Well, what's wrong here is if you look at the x-axis, this is the time dimension on the bottom of this page, you'll see that it starts in the year 1751. And the increments, and it goes in 30-year increments to 1781, 1811, 1841. But then something strange happens. It goes from 2001, 2010, 2011, 2012, 2013, 2014, 2015. And as we tell our students, if you allow me to change the x-axis or y-axis in any way that I want, I can make a chart look vastly different. And I can tell vastly different stories with those charts. So let's take that data and replot it with even years, which is typically what we would expect to see in a time series graph like this, time series line figure. So let's look at this. This is the exact same data of annual CO2 emissions. The one on the left has this funny way of representing the years where it goes in 30-year increments, then it jumps to 1-year increments, and it makes it look like it's stabilizing. If you just have even tick marks on the x-axis, you see a much different story. Same exact data. So that's what I want you to be thinking when you see a chart or a table around some health issue, around some news about entertainment or whatever you like to share. If there's data and there's graphics, you should be thinking, should I share or beware? Let me look a little bit closer at this graphic. And at least in this one, you probably want to be a little bit wary. You want to beware of sharing maybe this particular graphic and instead show this one. Now, to Statista's credit, they did correct this and they replotted it. And that's what we want to see, hopefully. But the best thing that you can do at first is to be able to call these things out. Let's look at another example here. This is a heat map of all the counties in the state of Georgia. And early in 2020, during the beginnings of the pandemic, there was a lot of discussions about what to do. It was a confusing time. It still is a little confusing when it comes to the pandemic on what to do next, mask or no mask. In this case, they were wanting to know whether they're going to close the economy or not, or shutter it down and have people and really restrict movement within the broader society. And so they were looking at data and then having those discussions. Now, this was one of the graphics that went around. And if you look at it, one was a heat map. So a heat map showing the number of cases in each one of these counties with these different colors. So red being extremely high. And they were comparing two different time periods, July 2nd to July 17th. And the question was, is it getting worse? And you can ask here again, share or beware. Pause a little bit. What could be going wrong with this very simple heat map? Okay, maybe you're back now after pausing. The reason why it's really difficult to use these two images to make the case, one way or the other, is that the bins used for making those colors are vastly different. So if you look here at the red, it's 2,961 to 4,661. The red on this side is 3,769 to 5,165. So if you look at these two images, they doesn't really look like much has changed. In that case, you might say, well, do we need to do anything? Really, should we require masks? Should we impose these different policies? But in fact, there was differences from July 2nd to July 17th. There were some changes. You can see that in the increase in the bins on this side. So then we could have a discussion whether you want to create these different policies. And you could at least have the argument based on the correct data and the best representation. And the point here is to really look out for even things like heat maps and all other ways of visualizing quantitative information. Now, in this case, I think they made an honest mistake. The Georgia State Department of Health said that they used software that was automatically scaling the data, and I believe them. I think there were some other mistakes from that particular department, but I think they were honest mistakes. And I think one thing that we try to encourage you is to not jump to claiming that there was malicious intent. Instead, just say maybe it was incompetence or an honest mistake, because we all make mistakes. So that's where we want to start. Now, sometimes there is malicious intent. There are efforts to intentionally mislead with data graphics, and we want you to be on the lookout for those as well. Okay, so let's go and sort of split the two main topics that we're going to talk about for the rest of the module, for the rest of the 10 minutes or so. So far, we've given some examples on data visualization, which is the primary way that we communicate with data. And we've talked about some of the things to look out for. I'm going to give you a few other examples, and then we're going to move to this topic called selection bias. It's one of the more important concepts that you can learn when being exposed to some argument using data. One of the questions you can always ask is this an issue of selection bias? So we'll talk about what that is and something that you can do when you're talking to your friends about something that you found in the news that involves data. Okay, so let's do some more examples of data visualization first, though. And I want to mention that these next two examples, or this next example with a couple different slides, was a virtual exhibit that we made with the Pacific Science Center. And you can go to this link up here. It's kind of hard to see. You can pause the video and you can look at other examples. If you're a teacher in the room, feel free to look at all the examples here that we have on this virtual exhibit with the Pacific Science Center, where we look at the ways in which graphics can mislead. So there's more examples than the ones I'm going to show. So if you want more, you can go there. And it's all free, of course. You just go to the website. There it is. All right, so many of you live in Seattle, but many of you don't, because this is across the state. But let's imagine that I showed this graph to you and I said, Seattle, the next Atlantis. Look at all the water that's coming into Seattle. And that could be the case, but let's look at that data. So let's assume the data is right. But let's look at this visualization a little bit more closely. Is this something you would share, or would you beware? Pause the video. All right. Some of you may have noticed, since the previous examples had some issues with the x-axis and the time series component of the graph here. So 1985, 1993, 2000. Well, where are some of these other years? There's a jump only of 2 years here, and this is a jump of 7 years. I guess if you take out the years that don't have very much rain, it might not show this pattern. And maybe if you put those years in, it would still have that pattern, but you should be asking, why are those years removed, and why were these years arbitrarily chosen as the years to represent the total precipitation? So if you drill in closely, of course, you should be aware here. You have, what's missing here in these particular years. You also see that it starts at 20. And what I'll talk about in just a second is that this violates the principle of proportional ink. So the inconsistent time ranges in the x-axis, huge gaps and years left out, made it hard to say anything accurate about change over time. And there's a deceptive baseline. The x-axis starts at 20. And if you're using a bar graph, you can make differences look very big if you zoom in a long ways. And so that's this principle of proportional ink that I'm going to talk about in just a moment. Well, this violates that principle, and I'll talk about what that is. So let's look at another example where a bar chart is zoomed in really far on the x-axis. So this looks at the Tennessee total non-farm acreage. I believe it's acreage. And what you see here are these different years. So at least they use 1 year consistently across the time series. But now what you're seeing here is that you've zoomed in. Look, it starts at 2,500, and it looks like, there's this increase going on, and look at the big difference that's going on from 1 year to the next. But if you could zoom in even further, what if you zoomed into 2,600? Those differences would look even bigger. The trend would look even stronger. When in fact, if you zoomed out with 0 included, at least with this bar chart, then you'd see, you wouldn't necessarily see the trend. Now with line graphs, it's a little different than bar charts. I'll leave that for another module. But for here, I want you to notice that this zooming into 2,500 makes it look like there's a pretty big difference from one year to the next. And that violates what we call the principle of proportional ink. That is, when a shaded region, like a bar graph, is used to represent a numerical value, the area of that shaded region should be directly proportional to the corresponding value. Now that builds off of an idea that Edward Tufte, a very famous individual for focusing the world's attention on information visualization. He's got some great books on this, where he talks about the representation of numbers as physically measured on the surface of a graph in Excel should be directly proportional to the numeric quantities represented. So let me give you another example. This was a story that was written about the trust differences between those that lived in Quebec in Canada and the rest of Canada. And you see this big difference between the red chart and the red bar and the blue bar. But you can see here it starts at 35. And again, if you kept zooming into like 36.00, you could even get a bigger difference. And so it is kind of ironic. This is about trust because it doesn't engender a lot of trust when you replot it and see that the differences aren't as big. They're there still. The differences are there. They did replot this to their credit when they were when people noted this problem with the graphic. We've updated the chart so that their x-axis starts at 0 while maintaining the accurate data that was previously illustrated. So very different when you look at this and this. So look out for violations of the principle of proportionality when you see bar charts, both vertical bar charts and horizontal bar charts. Now let me show you another common thing that we see a lot, and that is the misuse of cumulative charts. So when Tim Cook took over Amazon, he didn't take over Amazon, he took over Apple. I'm recording this on a late Friday afternoon after a long week, and sometimes you missay these things. But he had taken over Apple, and he was talking to his shareholders about this big growth in iPhone sales. And there was big growth if you look at 2008 to 2013, 2014. But he's showing a cumulative chart. And cumulative charts always go up. They never go down because they're adding all of whichever you're counting from the previous time period onto the current time period and so on and so forth. What would be more accurate if you really wanted to see how iPhone sales, at least we're doing right now, is to look at quarterly sales. And if you looked at quarterly sales, much different story. That leads to a much different discussion. And maybe, I don't know his intention, and I don't know that he was necessarily trying to mislead here, but if you want to make something look like it's growing when it's actually not, you can use a cumulative chart, but don't you do it to be manipulative. You should do it just to look out for them, ways of manipulating cumulative charts. And we see it all the time. We've seen it during the pandemic quite often. One chart that was put out with the White House and actually was published on NBC News and other places was this growth of COVID testing. And it looks like it's going up, right? That would be a good thing. We wanted lots of testing and needed lots of testing and continue to need testing during the pandemic that we're currently in and have been in for a couple of years. But if you look at this chart, it's a cumulative chart. Actually, the increase from one day to the next is not getting better. It's actually staying quite constant and maybe even getting smaller in some cases from one day period to the next, but it looks like it's growing a lot. So if you see a cumulative chart trying to make something grow when it actually isn't growing, ask to replot it from day to day and see if there's an increase from one day to the next, which is not the case here. Also, you may see strange charts like this all the time. This has nothing to do with principle of proportional ink, but we see these kinds of things all the time. This is looking at the 10 most in-demand developer skills of 2013. On the y-axis, you have language, which I have no idea how you quantify that. And on the x-axis, you have percent among top 10 searches. Huh? Doesn't even make sense. I have no idea why you would even use a chart like this and what the 45-degree angle and what these languages mean. The point with this example is to look out for silly graphics too, that aren't doing anything but trying to look sciencey and also trying to look authoritative. So look for those kinds of things, and you can call them out when you see them. All right, so now what I want to do, that was some data visualization examples. Let me just now talk about this selection bias issue. It's one of the more important concepts that really one of the more important concepts in data reasoning that doesn't require any real sophisticated training in statistics, or certainly not calculus or anything like that. All you need to do is look and ask whether whatever's being sampled in the study that's being presented or explained, if it differs systematically from the population at large. So let me give you an example, and it comes from a puzzle from the insurance industry. If you listen to commercials on TV or in the radio or during the Super Bowl, you see a lot of this. Switching over to Progressive saves you $500 on average. Well, same thing at Allstate, about $500 if you switch to Allstate. If you switch to Farmers, you save about $500. Geico, you save $500. How is it? And we've even gotten emails to our course site about saving $500. But anyway, okay. So how can every insurance company be about $500 cheaper than its competitors? It just doesn't make sense. How can that be? Well, pause the video for a sec. Everyone can discuss it for a second. What could cause that? So we're unpaused now with the video. We see this as a selection bias problem because assuming that that's correct, sometimes they just companies might just make up these numbers for their marketing campaigns, but let's assume they're all correct. How could it be that they all save $500? Well, there's a selection bias issue. If someone is willing to go through the trouble of getting new forms and finding a new insurance agent and switching over all their policies, then it better be worth their time. They're not going to switch for $5, and maybe they're not going to switch even for $100 on average. Some might. Most, on average, or I guess on average, people, this is what this says, that it takes about $500 to switch. So those that switch save $500, and that's about what it takes for someone probably to switch insurance companies. So that's a selection bias issue. It has nothing to do with any of these companies really saving you $500 more than another company would. So that's a selection bias issue. Now, it also explains why you might see, this is a great example of survival bias means this app will get fantastic reviews. You're essentially looking at an app that identifies mushrooms. As we all know, they can be incredibly dangerous. And so you have to be on the lookout for, I don't think I would use an app to tell whether a mushroom's edible or not, but that's a selection bias issue for those that were saying it was a great app because if they're not dead from eating bad mushrooms, then they're probably going to give it a good review. Those that got really sick might not, or didn't survive, wouldn't be writing a review. Let me give you one last example of selection bias. And that is that early on in the pandemic, there were dentists that were warning of prolonged mask use was leading to poor oral hygiene because they were seeing more and more individuals coming into their clinic with serious dental problems relative to just regular checkups. And they claimed a lot of it was due to, not enough oxygen in the exchange with their mask and all these other things, which aren't true. But this is a perfect selection bias problem. If you'd ask, well, who's coming in to the dental office in a pandemic? It's not people aren't going to come in usually for a regular checkup. If there's a major pandemic going on, those with serious pain will. So they probably did see a higher number of individuals coming in with serious cavity problems and pain problems because they couldn't sleep at night. Even during the pandemic, they were willing to come in. Whereas those that didn't come in were, the regular checkups just weren't coming in. So this is another example of selection bias. It had nothing to do with masks. All right. So I'm going to end here by saying that there are lots of ways of thinking about numbers. Of course, this is only a short module for MisinfoDay, but there are lots of things you can learn as well around tips of looking out for misinformation that comes wrapped in data. So I'm just going to end here by summarizing what we kind of talked about today. We're drowning in misinformation, and much of it's in quantitative form. It's not just in video and imagery. Look out for the ways in which numbers can mislead as well. The COVID pandemic has put this into a life or death context. Really, there's been a real need for students like yourselves and everyone in society for that matter to look out for the ways in which data can be so informed as well. Numeric literacy could literally save lives. We have a book on this. It has kind of a swear word, sorry to show, but we actually take it very serious. And we actually have a non-swear word version of our course, callingbull.org, where we have free videos and case studies and examples throughout. So thanks so much for listening to this module. Have a great Misinfo Day, and feel free to reach out anytime to our center and to any of us that work at the center. Thanks so much for listening.